Hello, and welcome to another Unity networking tutorial. So in this tutorial, I'll use the project from my previous tutorial and add functionality to pick up and drop equipped items. We'll also take a look at how you can implement object pooling using MLAPI. So in my previous tutorial, I talked a little bit about remote procedure calls, or RPCs. So in this tutorial, I'll also use RPCs, but I will not talk about them as much, but instead focus on other things, especially object pooling. So let's start by adding functionality to be able to pick up items. So I'll add a script with an empty class called item to the cube game object, so that we can identify the cube as a game object that we can pick up. And in my previous video, I added a network transform and a network object component to the cube. I will then rename the equip script to player actions, since it's now supposed to do more than just equipping. In this script, I'll add a boolean that decides if our player can equip or not. I'll also make it so that we can only equip if we have chosen an object to equip, meaning that equip item is not equal to null, and that we don't already have an object equipped. Then I will add the pickup logic when the user presses the control key. So in the try pickup function, I'll do a ray cast from the center of the camera. And if the ray hits a game object with an item component, we can set canEquip to true. We then call a function which only runs on the server using a remote procedure call, or RPC, and in this function, we'll first fetch the object, which has a network object component attached to it, from the spawned objects dictionary in the network spawn manager. We can then destroy the object, and MLAPI will automatically despawn the same game object on all the connected clients. So after actually calling this RPC, we can test out the project. And it seems to work fine. And if we pick up the cube on the host before the client has connected, when the client connects, the cube is properly despawned. So let's now add functionality to be able to drop items. So when dropping an item, I will tell the server to remove the ownership, which means that we return the ownership of the item to the server, which now means that the server controls its transform. Then from this server RPC, I'll call a client RPC, which tells all the clients to drop the item. And I'll also set the equipped item to null. So testing again, and both the client and the host can see each other dropping the item. Now, let's make our cube a weapon that spawns projectiles. So rapidly instantiating and destroying lots of game objects, such as projectiles from a weapon, can be really slow. So this is why object pools are used. So an object pool is a container which holds a list of already instantiated game objects. And then when we want to instantiate a new game object into our game, and in this case the game object is a projectile, instead of creating a new projectile, we can fetch one from our pool, and then when we later want to destroy it, then instead of actually destroying it, we can just return it to our pool. So for convenience, I will create an empty game object and call it object pool, and attach my object pool script to it. I will make the object pool into a singleton so that I can easily access it from anywhere. So in real applications, depending on your setup, you might want to have several different object pools, each of them responsible for storing a list of a specific prefab. But I chose to do it a singleton here, since I think that makes it easier to get a good overview of what's happening. I will then add a variable to hold the game object which we want to store in our pool. I will then create the actual container which will hold the game objects. So here I will use a queue, and that might not be the best choice depending on your application. So let's then add the game objects to the queue and set them to inactive. So in this example, my queue is very small and contains only 10 items. So how do we actually use this queue when we want to instantiate and destroy game objects into our game? So when a game object is spawned from the server or host, MLAPI executes relevant spawn functions on the clients, which instantiates a new game object. But now, instead of instantiating new game objects, we want to use objects from our pool. So we can override the default spawn and destroy behavior on the clients from the network spawn manager. So first we include MLAPI.spawning. Then to override the default behavior, we can register our own functions using register spawn handler. And the first argument to this function is the hash of the game object that the spawn function was called on. So I will put cube here and later change it when we have created a projectile prefab. So the second argument is the function that we want to run. So this function, it needs to have two parameters, position and rotation. So when spawn is called on the server, MLAPI calls our registered function on the clients, passing in position and rotation of the spawned game objects. So just to remind you, the function that we register is called on the clients when the server or host calls spawn, in this case on the cube game object. So when spawn is called on the server, we want our clients to fetch a game object from our queue. We also want to set that fetched object active and set the position and rotation. And MLAPI expects us to return a network object, so we will do that. So now let's register a destroy function. This function only takes one parameter, which is the network object to be destroyed. So I will create a new function called pool object, which will be responsible for deactivating the game object and putting it back into the queue. So just as in the previous case, each time the server calls destroy or despawn, our registered function will be called. I will also create an overload for the fetch object function, which we will use later. So now let's create some custom functions that the server or host can call when we want to instantiate or destroy game objects. I will start with the instantiation. So I'll name this function fetch from pool. In this function, we want to get a new object from the queue and then spawn that item. So notice here that when we call spawn on this item, MLAPI will actually call the function that we registered on the clients. So just to reiterate a bit, so when we want to spawn a game object, we let the server call fetch from pool. So this function will fetch a game object from the queue on the server, which will be enabled. Then when we call spawn on this game object, our registered spawn function will be called on the clients, and the clients will then fetch game objects from their own queues and enable them. Since the change ownership function seems to be a bit buggy at the moment, I will create another function called fetch from pool with ownership, which will spawn the object with ownership. But actually, I ended up not using this function anyways. I'll then create a function for the server to call when we want to destroy a game object. I'll name it return to pool. In this function, I will put the game object back into the queue, and I will also call despawn, which will then call our registered destroy function on the clients. So now our object pool is ready. So I'll quickly create a projectile prefab and also change the registered function in the object pool to projectile instead of cube. Then finally, I will add a very simple shoot function in the player action script, which will fetch a projectile from our object pool instead of instantiating a new projectile. So testing out our project, it seems to work as intended. And we can see that as we spawn, the inactive game objects in our object pool becomes active on both the client and the host. And as a quick final notice, if you get flooded by messages saying trying to destroy object but it doesn't seem to exist anymore, this actually seems to be a bug in MLAPI and should be harmless. And I've included a link down below to a fix. Anyways, thanks for watching.